So we're going to continue talking about solving different types of equations, and here we're going to talk about radical equations. And so when I'm thinking about a radical equation, I'm thinking, well, how would I even identify what a radical equation is? Radical equations have a variable under the radical. So they have radicals in them and they have a variable as what we call the argument. So if you look down here, we've got an equation with square root of x plus 1. So we're dealing with equations, solving equations that look like this. One thing that's going to be important for us to note is we have this principle of powers, and this is a pretty important rule. And what it says is if you have an equation right here, so something equal to something else, then what you can do is you can choose to raise both sides of that equation to the same power. All right? So we can raise both sides of an equation to the same power, and we'll determine the power using the index of the radical. So the index, if it was a square root, we would do power of 2. If it was a cube root, we'll do a power of 3. All right? So we always have steps that we can use to help us solve. The first thing we're going to do is isolate, and then we'll use our principle of powers, solve, and check. And it's very important for us to remember here that you cannot take the even root of a negative number. All right? You can't take the even root of a negative number. So remember, math, algebra is following a recipe, baking a cake. We just have to do everything in the right order, not break any rules. So the first thing we're going to do is isolate. And when I look at isolating this, that means I need to get everything away from the radical. So subtracting 1 from both sides leaves me with x plus 1 under the radical equals x minus 1. So step 2 would be to apply the principle of powers. And because we are dealing with a square root, it has an index of 2. All right, there's a little invisible 2 there. We're going to raise both sides to the second power. So I'll square the left and I'll square the right. And squaring a square root, those are inverse operations. So the square root goes away. I'm left with x plus 1 on the left. And on the right, when I square that, I actually have to FOIL it. So I've got x squared minus 2x plus 1 on the right. So at this point, we're left with a new equation to solve. We have to solve the resulting equation. Normally what we get here is something that's linear or quadratic. That's what you're going to expect to see. And looking at what we have with that x squared, that lets me know it's quadratic. So if I'm solving something that's quadratic, we want that in descending order equal to 0. And in order for me to make it equal to 0, I'm going to subtract x as well as 1 from both sides of the equation. So I'm going to subtract the x, I'm going to subtract the 1, and that leaves me with 0 equals x squared minus 3x. The 1 values cancel. So this quadratic factors, although not the traditional way we're used to, we pull out a GCF of x. So coming over here, I have 0 equals x times x minus 3. Just carried it up. So solving each of these factors equal to 0, I've got x equals 0 and x equals positive 3. Yay, we're done. We have 2 answers. Well, we need to make sure that they check because, as I mentioned before, You can't take the even root of a negative number. So we'll check both of these. The square root of 0 plus 1 plus 1 equals 0. So that doesn't check out. If I simplify the left side, I get 2 equals 0. What about if I check 3? The square root of 3 plus 1 equals 3. This one does check out. So what we know is that x equals 0 is an extraneous solution. I only actually have one value that works here. So the answer to this question is x equals 3. So we have another problem here on the page. The cube root of x minus 2 is equal to negative 5. So looking at our steps up above, we want to isolate the radical, apply the principle of powers, and then we're going to solve whatever's left, making sure to check, especially if it's an even root. In this situation, though, we have two things that are different than the last problem. One, the radical is already isolated by itself on one side of the equation. And two, it's an odd root. So we can take the odd root, the cube root of a negative number. Cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 equals negative 8. Okay, so in this case, it's already isolated. We would apply the principle of powers, and my principle of powers would let me know I'm going to raise both sides to the third power. That leaves me with x minus 2, and if I cube negative 5 times negative 5 times negative 5 gives me negative 125. So I'll add 2 to both sides of the equation, and I end up here with x equals negative 123, which checks. All right, so we've got two pretty basic problems here. They're easy to deal with. One thing I haven't addressed on this page up here in the top right, it says sometimes when we have more than one radical, we need to take some steps to isolate the more complex radical first. So we've got one last example in this section. The square root of x minus the square root of x minus 5 equals 1. So I'm going to do some rearranging, isolate the uglier radical. And in my opinion, this one is uglier than the other one, the square root of x minus 5. So here I have the square root of x minus 1, and if I move that over, is positive square root of x minus 5. So again, we'll square both sides of the equation, applying our principle of powers. So on the left, when we do this, this gives us something we have to FOIL. I've got the square root of x minus 1 times the square root of x minus 1. The right just turns into x minus 5. So foiling this, square root of x times square root of x is x. I'm going to get, for my inner and outer terms, I'm going to get negative root x twice. So minus root x is minus 2 root x. And negative 1 times negative 1 gives me positive 1. So you see, after that foiling, I now only have one radical. So we're going to repeat that process again to go ahead and isolate what we're dealing with. All right, so this is, I'll subtract the x from both sides. I'll subtract the 1 from both sides. That leaves me with negative 2 root x equals -6. I'll divide on both sides by -2. And that gives me that square root of x equals 3. So if I have square root of x equals 3, I can apply my principle of powers again, squaring both sides, and that will leave me with x equals 3 squared, or x equals 9. And of course, you want to check and make sure that works out. So the square root of 9 minus the square root of 9 minus 5 equals 1. And that is 3 minus the square root of 4 is 2 equals 1. It checks. We're good to go. We're done and we're happy.